Not only do we use whole numbers, but also parts of whole numbers as well. We're going to study this by looking at fractions. A fraction is just division with a fraction bar, and the number on top of the fraction is the numerator. The number on the bottom is called the denominator. So 5 divided by 43 is the same thing as 5 over 43. And 86,450 divided by 711 is 86,450 over 711. The numerators are 5 and 86,450, and the denominators are 43 and 711. Suppose I buy a candy bar and split it evenly among myself and 2 friends. So there's 3 people in total. We're going to each get equal part. That means we each get 1/3 of the bar. If we take the full bar, split it into 3 equal parts, then each one gets 1/3. 1/3 isn't just for this case, though. It describes a lot of situations. And you can see that here, each one of these describes the exact same fraction of 1/3. 1/3 of this shape is shaded. So that'd be 1/3 of this circle, 1 bar here, 1 triangle, and 1 of the 3 stars. It's all 1/3 that's being displayed there. Of course, we can talk about a lot of different kinds of fractions. With a pizza cut into 8 parts, each slice is 1/8 of the whole pizza. A football field, you're going to ignore the end zones. And just looking at this portion here, right, each one of these 5-yard lines is 1/20th of the full field. And of course, if like a book had 27 equal length chapters, it has to be equal length to really be talking about it, though, which is not very typical for chapters. But if a book had 27 equal length chapters, then that means each chapter is 1/27th of the whole book. Of course, we'll go back to pizza. If we take a look at this pizza and we ate 3 slices from that pizza, and that's going to be 3/8 of the whole pizza as eaten. And you can count 1, 2, 3, 4, 5. 5/8 remain. So we have 3/8 eaten, because you can count 1, 2, 3, and then there's 5/8 that remain. All right, what fraction is being described by these images here? Well, here we have the whole is 9 pieces. So we know that the whole is going to be 9. And the part is going to be 1, 2, 3, 4, 5. So there's 5 parts out of the whole 9 that's shown. So 5/9 is the fraction. Same thing for this one, right? Here we have 4 by 4. 4 by 4 is 16, or 4 times 4, 16 total boxes. And of that, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 are shown shaded out of the total 16. So 9/16 is the fraction shown. For the next one here, we have 4 of these circles shaded in out of the total 8 that's shown. So we have 4/8 is that fraction. Okay, there's lots of different ways we can represent this. I've already shown you a bunch of different ways. Probably the easiest way is to do like boxes here. So like 3/4, right? If we just take a whole and cut it into 4. So here we have 4 parts make up this whole. And to show 3/4, all we have to do is just shade in 3 parts, 3 of those 4 boxes. Likewise, I could do it like this, where I have 4 circles, and I'll do something to the 3 of them, so I'll create an X on them. So 3 of these circles have X's, and then 1 does not. So 3/4 is shown. You could also have a lot of different things. Let's say we have like the circles now in a line, and instead what I'm going to do here is I'm going to circle 3 of them. So here is 3 out of the 4 total. So that's the same thing as 3/4. You can come up with many different representations of 3/4. Now, once again, the top number in a fraction is the numerator, and the bottom number in a fraction is the denominator. When the fraction is a over b, where a is less than b, in other words, the numerator is less than the denominator, this is called a proper fraction. Because we're talking about a smaller part of a whole, which is typically what you think of as a part of a whole. However, when a is greater than b, the numerator is bigger than the denominator, we have an improper fraction. And these improper fractions can be written as mixed numbers. Mixed numbers are useful for application, to understanding what you're talking about. In general, improper fractions are much more useful when doing mathematics. So let's take a look at this one here. We have two parts, or I should say two whole things, like a pizza or a pie or something like that. And out of these, we have each one has five parts. Of course, of these, we have in total these 5 and 3 more that are completely shaded in. So in total, that's going to be 8. 8 is shaded. And for a single whole, right, a single one of these circles is just 5. That means we have 8/5 being shown here. This is an improper fraction, right? The numerator, the top, is larger than the denominator, the bottom. I can rewrite this as the same thing as 1, because we have a whole one here shaded in, and we have 3 shaded here out of the 5 total. So 1 and 3/5. This is the mixed number version of this, what's being shown here, and the improper fraction version. So the 1 and 3/5 kind of makes more sense for this diagram because we have 1 whole one and 3/5. The 8/5, however, is more useful when you're doing mathematics. Okay, express them as an improper fraction. To show a mixed number as an improper fraction, the algorithm is really easy. The algorithm is just the steps that we're going to take to show this. We're going to take the denominator, we're going to multiply it by the whole number, and then we're going to add that onto the numerator. When I do that, I have 4 times 2 is 8, and then 8 plus 1 is 9. So 9/4 is the improper fraction version of 2 and 1/4. They both show the exact same relationship. They're the same number. Now, same process for this one here. We're going to multiply the denominator by the whole number. 3 times 12 is 36. And then we're going to add that onto the numerator. So we're going to multiply and then add. 36 is 3 times 12 plus 1 is 37. Okay, same process here. Multiply. 5 times 6 is 30. Add on to 4. We're going to get 34 over 5. And then here, 7 times 1 is 7. Plus 1 is 8. Now, to go the other way, all we have to do is ask how many times can 5 go into 42? And you can do this by just looking at multiples of 5, or you can do it on a calculator as well by doing 42 divided by 5 and taking the whole number that shows. You're probably going to get a decimal number, but the whole part is what we care about. 5 can go into 40 8 times evenly, because 5 times 8 equals 40. And that gives us a remainder of 2, because if we take 40 away from 42, we're going to get 2 as a result. 42 minus 40 is 2, and we're going to keep the same denominator. So what I've done here is I've said 5 can go into there 8 times evenly, and I'm going to take this whole part out of what I've got in the numerator, and that leaves me with 2 as a remainder. So 8 and 2/5. The nice thing about this is that you can always check your answer by just taking, doing the algorithm I showed you. 5 times 8 is 40, and then add it to the numerator, we get 42 over 5. So I've done the work correctly. Whenever you're doing this, make sure you have the same denominators. Okay, 9 can go into 53. 9 times, let's see, 9 times 4 is 36. I can go further. 9 times 5 is 45. 9 times 6, however, is 54. That's too high. So 9 times 5 is 45. So 9 can go into 53 5 times evenly. And then 53 minus 45 is 8. So we have 9 times 5 is 45, plus 8 is 53. So that checks out. Once again, I have the same denominator, and I can check to make sure my work is correct. Also, it's important to note that when I do this side fraction here is always a proper fraction. If you have an improper fraction on the side there, you've done the first part, the whole number part, incorrectly, and you have to rethink through how many times the denominator fits into the numerator. 25 can go into 42 only one time evenly. 25 times 2 is 50. That's too much. So we're going to take 42 minus 25, and that's going to give us, let's see, 17, I believe. 25 times 1 is 25, plus 17, it's going to be 42. Yes, that's correct. And finally, 7 can go into 73. Well, 7 times 10 is 70. And then, of course, 7 times 11 is 77. So I know it's going to be 10 times evenly. And 7 times 10 is 70, minus 73 is going to be 3 remainder. And you're always going to have the same denominator. 7 times 10 is 70, plus 3 is 73. So I've done the work correctly. Okay, we're going to draw accurate diagrams to represent each of the fractions below. 5/8, I think an easy way of showing this is just to draw a box. An eighth is going to be, here's 4th, and then cut it in half again. Here's an 1/8. So 5/8 is just like that. 5 out of the 8 is shaded in. 2 1/3, let's use circles like I've seen before. And then we're going to cut them each into thirds. Estimating, of course, the actual thirds. We're going to have 2, so it's going to be fully shaded there, and then 1/3 is just that one portion shaded. 6/5 is going to look like this. And I'm using 2 bars here because this is an improper fraction, right? I can rewrite this as 1 1/5, which means I'm going to have 6 of these things shaded. So here's 5, and then an additional 1 makes 6 of them in total. That's the same thing as saying 1 full one is shaded and 1/5 of another one is shaded. So both of them are the exact same. Finally, we have 0 out of 2. If I have 2, here's 2 parts, and I shade 0 of them, then this is my answer here. 0 out of 2 has been shaded. Okay, which of the following can be written as a mixed number and why? So first off, we have a mixed number is going to be the same thing as an improper fraction. So really what we're looking for here is which ones of these are improper fractions. Improper fractions are where the numerator is larger than the denominator. So 8 divided 8 and 3, right? The numerator is larger than the denominator. This is an improper fraction. So this one can be written as a mixed number. And specifically, 3 can go into 8 2 times evenly. 2 times 3 is 6. 8 minus 6 is 2. So you get 2 2/3. So that right there is proving that it can be written as a mixed number. This is also an improper fraction, so that means that this can be written as a mixed number, specifically 1 7/8. This is a proper fraction, so this cannot be written as a mixed number. There's no way, right? 25 cannot go into 21 at all. So there's no way of doing this process that I've done for both of these. So this one can't be written as a mixed number. This one can, it's improper. We're going to be 1 7/27. This one cannot. It's a proper fraction. And finally, 7 can go into 84. This one's not technically a mixed number because 7 can go into 84, I believe, 12 times evenly. And there's no remainder. There's no fractional part. So this is just a whole number. It's not a mixed number. It's a whole number. So this one isn't really, it can't really be rewritten as a mixed number. Fractions are reduced when the numbers in the numerator and denominator are the smallest they can be, but still describe the same quantity. There are infinitely many ways we can describe a fraction. I've just shown you a few, but as you can see here, if I wanted to show the fraction 1/2, I can draw a circle and shade in a half. However, that's the exact same thing as just cutting this thing into a half again and shading in two sides. So this is 1/2, and this here is 2/4. If, however, I cut it again, every single part into a half again, this is 4/8. I have 4 shaded out of the 8 total. And finally, if I do this and shade in all these sides here, this is going to be 8/16. But you'll notice in each one of these cases, really all we're shading in is half of the circle. So all these things have the exact, are representing the same exact quantity, but they're different ways of showing it. And when we talk about reducing fractions, we like to have it in the smallest numbers possible, which is going to be 1/2 in this case. But to really understand how to do that algebraically with, working with fractions themselves and reducing them, just with the numbers and not with diagram, we have to understand the fundamental theorem of arithmetic.